Hello everybody and welcome to another math video here. Today I'm going to be showcasing some logarithmic differentiation. Okay, and I have some questions here with increasing difficulty, and I'm going to walk you guys through the steps of how we can take the derivatives of these functions. Okay, so we're going to have to use what we learned from implicit differentiation and use our rules of logarithms as well to try and find the derivatives of this function. Okay, so the first thing that you want to do when you're taking the derivative using logarithmic differentiation is you want to take the natural log of both sides. Okay, so I'm going to take the natural log of both sides here, and then we are going to take this x. Using our rules of log, right, I'm going to take that x, I'm going to move it out to the front, okay? So I'm just going to rewrite this. I have natural log of y is equal to x natural log of x, just like that, okay? Now we can go ahead and differentiate implicitly from left to right, okay? So here we have the natural log of y, which is a function of x, right? We know y is equal to x to the power of x, right? So because this is a function of y, I need to sort of use the chain rule here, right? My outside function is my natural log of a function of x, and then I have my inside function of x, which is y. So it's going to look something like this. The derivative of the outside is just going to be 1 over y, because the derivative of natural log of x is 1 over x. This time we have the y, which is a function of x, so we're going to put 1 over y. And then we're going to multiply by the derivative of the inside function, which is going to be our dy dx. Okay? So that's what we have on the left-hand side. On the right-hand side, we have product rule. Okay? X, the function, natural log of x, another function, okay? So, taking the derivative of the first function, leaving the second one alone, that's just going to be 1 multiplied by natural log of x, plus leaving the first function alone, x, multiplied by the derivative of natural log of x, which is just 1 over x. We can see here that my x's cancel out there, so I'm just going to be left with a 1. Okay, so rewriting this, I have 1 over y dy over dx, or dy dx. We have natural log of x plus 1. Okay, now what we want to do is I want to isolate this dy dx over here. Okay, so we're going to have to multiply the whole thing by y. So my y's on this side, they're going to cancel out, and I'm just going to be left with a y on this side here multiplied by this whole thing, right? Okay. So going down here to the next line, we have dy dx is equal to, now here instead of writing y, I'm going to go ahead and write what my actual function was, right? So I'm going to plug in what y was up here, x to the power of x, right? So I'm going to go ahead and put x to the power of x at the front, and then inside my bracket I have natural log of x plus 1. That's your final answer there, okay? Moving on to the next question here. Okay, so we're going to follow this blueprint here. Same thing we did here. We're going to take the natural log of both sides, we're going to differentiate implicitly, and then at the end we're going to be multiplying by the y and replacing our y that was originally given, okay? Alright, so draw a line here. Okay, so taking the natural log, that's step number 1, right? So here we have the natural log of this whole function inside here. Our rules of logarithms say that if I have the natural log, or the log of base of anything, of one function over something else, I can split them up in this way. So I'm going to just rewrite that. I'm going to have natural log of y, natural log of x cubed, minus the natural log of x plus 1 squared, okay? Now, over here, same thing that we did up here, right? Once we took the natural log, I took that exponent, I moved it down. I'm going to move these exponents down. I'm going to take the 3, move them down to the front, 2, move it down to the front, okay? So I have natural log of y, 3, natural log x minus 2, natural log of x plus 1, okay? Now we go ahead and use implicit differentiation, okay? So here we have the same thing that we have on this side, right? 1 over y multiplied by the inside function dy dx is equal to 3 is just a constant, it comes along for the ride. The derivative of natural log of x is 1 over x, so it's just going to be 3 over x, okay? Minus 2, that comes along for the ride. The derivative of natural log of x plus 1 is 1 over x plus 1. So I have x plus 1 on the bottom, multiplied by the derivative of this inside function, which is just 1, so it's going to give us the same thing. So I'm not going to write it down, okay? Now, last step, multiplying by this y, right? I multiply by the y on this side, and I multiply by the y on this side, but I'm going to go ahead and replace my y with this thing up top, okay? So if I have a y here, my y's are going to cancel out, and if I have a y on this side, I'm going to have this part. But I'm going to take this part, I'm going to write it in the front, and then I'm going to write out my bracket, okay? So we have dy dx is equal to, just copying down this part, x plus 1 squared. And then inside my bracket, you got 3 over x minus 2 over x plus 1. That's your final answer right there, okay? All right, last question here. Whoa, we got a doozy here. Okay, so same thing, taking the natural log of both sides. Now we have this whole thing on top. Okay, so we're gonna split it up step by step to show you guys what's going on here, okay? So I'm gonna put the top the same way we did up here. We have the top part, right, minus the natural log of the bottom part, right, using our rules of log. So we have natural log of y is equal to natural log of, here we have x squared plus 1, x plus 4 under the square root, oops, just like that, okay, minus the natural log of 2x plus 1 squared, okay? All right, now we can further break this down, right? Because I have this right here. When I have the natural log of a product of two things, I can split them up and put an addition symbol in the middle, right? So I can go natural log of x squared plus 1 cubed plus the natural log of square root of x plus 4, okay? So I'm going to go ahead and rewrite it that way. Natural log of y is equal to natural log x squared plus 1 to the power of 3 plus natural log, square root is just an exponent of 1/2, so I'm going to go ahead and write it out that way. I have x plus 4 to the exponent of 1/2, and here on the end I have my natural log 2x plus 1 squared. Running out of room there, sorry. Okay, now same rule that we used here, my exponent, now I can bring it over the front, okay? I'm going to bring them all down to the front, and I'm going to go ahead and implicitly differentiate this whole thing. This one's going to be the same. It's going to be the 1 over y multiplied by dy dx. So I have 1 over y dy over dx is equal to, here I have 3 natural log x squared plus 1 plus 1/2 natural log x plus 4 minus 2 natural log 2x plus 1. Okay? sorry. Not implicitly differentiating yet. My apologies. We're gonna implicitly differentiate on the next step, right? I just moved the exponents down to make it easier for us to differentiate here. Okay, now we have our 1 over y dy dx. Differentiating this part, I have 3 on the top. The derivative of this part is natural log of x squared plus 1 over the x squared plus 1, the inside, right? Now we have to multiply by the derivative of the inside function, the x squared plus 1, which is just going to be 2x, right? So this is going to be multiplied by 2x up here. So instead of the 3, I'm going to have 3 multiplied by the 2x, which is just going to be 6x, okay? Here we have a 1 on top, right? On the bottom I have a 2. I also have x plus 4 multiplied by the derivative of the inside function, which is just a 1, so it's going to remain like that, okay? Then over here, I have minus, it's going to be 2 on top, divided by 2x plus 1 on the bottom, multiplied by the derivative of the inside function, which is 2, so 2 times 2 on top is going to be 4. Just like that, okay? Now, same thing that we did here, we're multiplying by y on both sides, right? So my y's here are going to disappear, and then this is going to be multiplied by y, but our y is this whole thing. So I'm going to replace it, okay? I'm going to write that top function out first. I have x squared plus 1 cubed multiplied by root x plus 4 divided by 2x plus 1 squared, and then this whole thing in here, okay? So I got 6x over x squared plus 1 plus 1 over 2x plus 4 minus 4 over 2x plus 1. Okay? Whew. Getting a little bit tight there on the end. But yeah, so as long as you follow those couple steps that I mentioned there, and you take everything step by step, it shouldn't be too bad. It does get a little bit messy, but just try and take your time, and you should end up with the right answer. Hopefully. Hope you enjoyed the video. Have a good one.